We are given this equation. The union of 20 sets labeled x1, x2 and so on till x20, which can be expressed as x1 union x2 union so on till x20. This can be expressed in the shorthand as the union of xr, where r varies from 1 to 20. So this expression on the left hand side is the union of 20 sets x1 to x20. This union is mentioned to be equal to the set S, which in turn is equal to the union of n sets of the form y1, y2 and so on till yn. So we are taking the union of all of these n sets and expressing it in a shorthand notation over here. Here we are taking the union of 20 sets and expressing it in the shorthand notation here. Now each of these 20 sets contains 5 elements, and each of these n sets contains 2 elements. If each element of S belongs to exactly 10 of the xr's and to exactly 4 of the yr's, then what's the value of n? Let's first look at this part of the equation. We are taking the union of 20 sets and we are saying the result is the set S. Each of these 20 sets contains 5 elements each. So if we had just collected together the elements of all of these sets without removing any duplicates, we would have had 20 times 5 or 100 elements in the collection. But of course many of them are duplicates, and so we just remove them all and we end up with the set S. Now we are given that each element of the set S belongs to exactly 10 of the xr's. This means each element in the final set S had appeared 10 times across these 20 sets, and this applies for every element in S. So if there were a total of 100 elements and sets of 10 of them were taken and mapped to one single element in S, then how many distinct elements are there in S? 100 divided by 10, which would be 10. So there are 10 distinct elements in S. Why? Because each distinct element in S maps to 10 instances in these 20 sets, maps to 10 numbers in these 20 sets. So if there were 10 distinct elements in S, they would map to a total of 100 different elements across these 20 sets. And we know that there are indeed exactly 100 elements across these 20 sets put together, because there are 20 such sets and each set contains 5 elements. So there are 10 distinct elements in S. So the set S has 10 elements. Now it's also mentioned that each element of S maps to 4 instances across these yi sets, across these yr sets, sorry. So if we take each of these distinct elements and map them to 4 instances in the yrs, there would be a total of 40 instances across the yrs. And of course many of these are repetitions of the same element, because it's we are given that each element of S is mapping to 4 instances of the same element across the yrs. So there are a total of 40 instances across the yrs, and we are also given that each yr has exactly 2 elements. So the total number of elements across the yrs, basically this would be the sum of the number of elements in each of the yrs. That would be 2 times the total number of such sets, 2n. Now we know that this 2n should be equal to 40, because there are a total of 40 instances of elements across the yrs, which map to 10 distinct elements in S. So if 2n is 40, n must be 20.